All right, finally, the last page. Whew. So we're gonna do this two problems at a time. I'm just gonna run over there and scooch them down as we go. I think it's a little bit easier to see. So for 15 and 16, we're gonna use the table. So every time it says use the table, right? I'm gonna come over here, I'm gonna check out the table. Take a peek at that. So what is the value of the digit 7 in New Mexico's average rainfall? So I've gotta go over to New Mexico and I look at it. So it's 7, right? So I'm gonna write 7. And then what place value is it in? Is it the tenths, the hundreds, or the thousands, right? See how I said that? Tenths, hundreds, thousands. So I'm gonna go that way. Tenths, hundreds, thousands. This is 700s. And we'll write it like this to keep it fast. Which of the states has an average annual rainfall with the least number in the thousands place? So that's step 1. I'm always going to read the whole question, the least number in the thousands place. And what is another way to write the total annual rainfall of that state? So I'm going to write it as a decimal form, but let's take a look. Least number in the thousands. So the thousands. I know that's 3 spaces from a 1. So I'm going to go all the way over. There's my ones, tenths, hundreds, thousands. I'm going to find the smallest number. 4. That's pretty small, right? 2. Smaller than you. 1, ooh, even smaller. Over here, I've got a 0 in Wisconsin, and then 4. So 0 is the smallest number. So which state? Wisconsin. Okay. Has the lowest. Now, it says, what's another way to write that? So I'm going to write it down as 0.820. Okay. What's another way to write this? Like, remember what I said earlier? I can write 0.820 and I can add as many zeros as I want, right? I can just go crazy. Well, I'm not going to do that. Instead, I'm going to be a little lazy. I'm like, you know what? This is too much. Well, the same thing holds true. If I have a bunch of zeros on the end, I can also take them off. I can take every single zero up until I get to a number that's not a 0. So I'm going to go, nope. Nope. Oh, that's a 2. It's not a 0. I have to leave it. What's another way to write this? It equals 0 and 82 hundredths, right? But it also would equal any number of zeros that I wanted on the end. I can write that a bunch of different ways, right? It's actually infinite. However many zeros you've got time to write is how long you can make it. All right? So that's 15 and 16. Go ahead and pause it here if you need to. I'm going to scooch this up to 17 and 18. Sloop. Okay. So when we look at 17 and 18, verify the reasoning of others. So we've got Damien. He's like, hey, man, I'm going to write this number. And it says 4 and 23 thousandths. And remember, the and is a decimal. So I'm going to put that there. Okay. And he wrote it as 4 and 23 what? Remember, we label it by the last digit. The last digit is in what place? It's 2 spaces from the ones. So it goes tenths, hundredths. So Damien wrote, we're going to write this way, 4 and 23 hundredths. Well, if I want it to be 23 thousandths, where does the last digit have to end up? In the thousandths place. So to write it right, I would have to write 4 and I'm going to write 23. Okay, it says 23, but where I want this to be in the thousands. And remember what I've been saying, most of the time, whenever I want to add something in decimals and division, it's going to be a 0, right? I can plug in a 0 here. So I'm going to plug in that 0 right here. Now read it. 4 and 23, but now it's in the thousands place. All right? So remember this magic 0. What's my favorite number? 0. I love it. It's great. All right. Dan used a meter stick. That's pretty smart because that's a base 10 numbering system, measurement system, to measure some seedlings in his garden. One day, a corn stalk was 8,500 meters tall. A tomato plant was 850 thousandths meter tall. A carrot top was 85 thousandths meters tall. So which plant was the shortest? Whenever you see something like this, write them out, okay? And look at them next to each other. So what I'm gonna do is I'm gonna go, okay, I got corn stalk. That is 0 and 85 hundredths. 0, 8, 5. Okay, cool. Now I've got a tomato plant, that's TP, right? That equals 0 and 850 thousandths. So I'm gonna write that. Okay, and now I've got a carrot top, which is 85 thousandths. Whoa. Okay, now here's where they're gonna try to trick you, and this is something I want you to remember going forward. Oh, that one's the shortest because it has the fewest numbers, right? No, that is not true. Okay, it's got an 8/10. One thing that I would do if I were you, and I'm not, but if I was, I would make them all the same length because it gives me a better view. Remember, these two are actually equivalent. I can add a 0 here, and now I can look at the numbers, all of them, and I go, that's 850, that's 850, that's 85. Well, it's bigger, 85 or 850? 850 is bigger, so 85 thousandths is the smallest. So the carrot top, CT, is the shortest. All right, it equals 85 thousandths. That's much, much, much smaller. If I cut it into 1,000 pieces, I'd have 850 of them. Over here, I'd have only 85 of those 1,000 pieces. So that's way smaller, all right? Okay, and then if you look at them just like whole numbers, like that, 850, 850, 85, right? Okay. All right, I'm gonna scooch this up, so pause it if you need to, or replay it. We're almost done, woohoo! Okay. I'm gonna racy. All right, explain. I'm gonna use our words here. How you know that the digit 6 does not have the same value in the numbers 3 and 675 thousandths and 3 and 756 thousandths? Well, you can answer this a whole bunch of different ways, right? Number one, when I read the numbers, they're different. They don't sound the same, so I know that it's different. But they're in different what? What do we call these, right? I have numbers and I have place values, right? This number 3, right? That's the number 3. And if I write it like this, well, that's still the number 3, but its value is 30. Now its value is 300. Now its value is 3,000. So it depends on what place I put it in for what the value of the number is. The number stays the same. It's still 3, but it's 300, 3,000, 3 million, whatever, right? And so here I've got 6 tenths, and here I have 6 thousandths. So they don't have the same value because they're not in the same place. All right, so forgive my penmanship, but they don't have the same value because they're not in the same place. Place, value. Numbers to have the same value have to be the same number, right, and in the same place. Okay. All right. Value of the underlying digit. So I would take this out of here. What's the value of that? So I'm going to write it 0.080. I'm just going to take all the other numbers out. Okay. Now, what can I do with the 0? I can definitely cross that off, right? Which also equals 0.08. So I'm going to take these numbers out and I'm going to write them down. It's a strategy that I have, right? I want to just see it by itself. Now, what do I do? Do I see this number anywhere over here? I do. It's here. I see some words here, so I'm going to read it. That's 8, but what value is it? Based on its place, right? It's in the hundredths. So I'm going to look. Do I see 8 hundredths? I see 8 tenths. I see 8 hundredths. I know that that is the one. Because it is in the hundredths, can it be this one? Nope, because that's tenths. That's also tenths, and that is tenths. So, boosh, skadoosh, and we are done. Homework is the evens. I'm going to attach a quick little homework one. All right.